Hello student, welcome back to the channel. Today we are going to discuss the next chapter of 11th topic, that means after basic concept of chemistry, which is nothing but atomic structure, which is comes under the physical chemistry, and atomic structure has a very good weightage for JEE mains and as well as JEE advance. Now in atomic structure, beginning part are very easy. You need to know what are the subatomic particle, how they discovered, like proton discovery, electron discovery, like cathode ray experiment, anode ray experiments, molecular end of experiments, E by M ratio, and what are the charge of electron, what are the charge of proton, what the charge of neutron, and then what will be the mass of electron, what will be the mass of proton, what will be the mass of neutron. This basic idea you need to know. After that, very important topic, which is nothing but a Rutherford experiment. From 9th standard onward, you people are very well accustomed with this topic. But there are few certain things is there. Most of the teacher is not explaining. My perspective or my aim is to explain that one and to make you well understood Rutherford experiment, as well as to make you for the upcoming JEE mains and advanced exam. Now, in the Rutherford experiment, everybody knows there will be one source will be there. This source will generate the alpha particle. What is alpha particle? Alpha particle is a helium nucleus. Helium nucleus, and it holding 2 unit plus 2 unit of charge, and mass is nothing but a 4 unit of mass. So mass is nothing but a 4 unit of mass of proton or neutron, because the mass of the atom is contributed by the mass of proton and neutron, and their mass is almost same. One is 1.672 into 10 power of minus 27 kg, another one is 1.674 into 10 power of minus 27 kg. So almost they are equal. So now whereas electron mass is 9.1 into 10 power of minus 31 kg. That's why mass of electron is not contributing the mass of atom. The mass of proton plus mass of neutron is the mass of the atoms. Now from this source, alpha particle used to go through a one lead block will be there, where there will be one small hole will be there. With this it will goes, and here you have a gold foil. This is your gold foil, and outside of a gold foil round there will be a fluorescent skin, which is zinc sulfide. Now maximum alpha particle will go like that without any deflections. They will go like this, they will go. There are few alpha particle, there will be little deflections will be there, like little deflections will be there, few alpha particle, and out of 20,000 one alpha particle will go and state will come back. That means rebound it. That means there will be U-turn in 180 degree. So out of 20,000 one alpha particle. This was the experiment, and there will be that alpha particle making an impact on zinc sulfide skin, which is a fluorescent in nature, and out of 20,000 one alpha particle exactly went stayed and rebound. That means U-turn it's taken at 180 degree angle. From this experiment, what Rutherford conclude? Rutherford conclude like that there is a small region is there in atoms, small region is there where positive charge concentrated. Later on discover this proton and neutron is there in a nucleus, and this is called as a nucleus, where there will be a proton and neutron. What will be there? Proton and neutron. This is first point. Second point, maximum space of atom are vacant. Maximum space of atom are vacant. Why? Because are vacant. Why? Because maximum number of alpha particle passes without any deflections. So that proves that maximum number space of the atoms are vacant. Gold foil means it's made of a gold atom. That's why we are explaining in terms of atoms. Now, third important point, very small alpha particle is getting deflected because positive there will be repulsion. Nucleus part of the atom is a positive part. So that's why there is a deflection. That's why I write down there is a small region is there where positive charge are concentrated. So now small alpha particle reflected slightly because of repulsion of positive repulsion is there. Alpha particle is a positively charged particle. Nucleus also positively charged particle. Repulsion will be there, slight deflected. And first point is proved like that. There is a very small place where there is a nucleus is located into the atom. That's why out of 20,000 one alpha particle is exactly taking 180 U-turn. This was the experiment and this was the consequence and conclusions from the Rutherford. Even after that, Rutherford says there is a small place nucleus of the atom is there, an electron moving in a circular orbit. This is a nucleus, this is an electron. Now there are scientist community, then they put a question. As per the Planck's theory, whenever any charged particle is moving around a nucleus, constantly moving, it will lose its energy, as well as slowly when it will start losing its energy and one time it come and fall into the nucleus. That means the structure of atom will not exist. That is the Rutherford drawback. Rutherford used to say there is a small region is there where there is a nucleus, which is later on discovered it's a proton and neutron will stay in the nucleus, and around this nucleus electron is moving in a circular path which is called as a orbit. And now then scientist community ask a question, okay fine Rutherford, no issue, but whenever there is a charged particle is moving around a nucleus, it will constantly losing its energy. When it will start losing its energy, then the path will slowly will small and then it will falls down onto the nucleus. That means structure of atom will not exist. Then how you are explaining the thing? Then Rutherford, this point was demerits of a Rutherford. And after that, the scientist Niels Bohr discovered that vibrant atomic structure, and because of that 1912 he got the Nobel Prize. Now in this Rutherford experiment, you look at out of 20,000 only one alpha particle is giving this type of behavior, that means 180 U-turn. And from there question used to come, closest distance approach. Then one alpha particle, how much close can reach to a element of atom, that questions, and that I am going to explain into the next slide. Look into that one, very important idea. Now if you look at that, suppose I am telling an alpha particle, let us take in the form of a problem, an alpha particle started with a velocity 2 into 10 power of 5 meter per second towards an element Z equals to 29. That means atomic number 29. Which element? The element is a copper. Then they are asking how much closest distance alpha particle can move. Why? Because they are asking these questions, my dear student, because alpha particle is a positively charged particle and nucleus of any element of atom, that is also positive, there will be repulsion, you know very well. So then like charge there will be a repulsion, unlike charge there will be attractions, like positive repulsion, positive negative attraction. So that's why whenever that alpha particle is a positively charged particle, it's a helium nucleus, 2 unit positive charge and 4 unit mass. That means that 4 into mass of 1 proton or 1 neutron. So that's why alpha particle, helium nucleus, already you know, this is your helium nucleus, this is alpha particle. Only difference with helium has a 2 electron, but alpha particle don't have that 2 electron. That's why 2 unit positive charge plus 2 unit charge will be there. That is nothing but a alpha particle. Mass equals to 4 into mass of 1 proton or neutron, whatever it is, their mass almost equal to, mass of proton will be equals to 4 your 1.67 into 10 power of minus 27 kg. This is the mass of proton or neutron. Now if you look at, alpha particle is starting from this point, suppose it is going, and here suppose your copper nucleus is there. Maybe this is the approach, closest approach. After that it will start taking the U-turn. Now this distance they are asking, which is nothing but I am telling R0 is the closest distance. This is your nucleus is there. So R0 is the closest distance. It can approach. After that it will take a U-turn or rebound it. Now whenever this is alpha particle is starting point, this is your starting point. Now whenever it is starting, then it's starting with that velocity 2 into 10 power of minus 5 meter per second. Now in starting, here my total energy will be equals to, this point I am telling 0.1, in middle point anywhere I am telling 0.2, and this point I am telling 0.3. Is it clear? Now in starting point, total energy I am telling T1, which will be equals to kinetic energy 1 plus potential energy of starting point 1. Total energy is a summation of kinetic energy plus potential energy. Now here the potential energy part almost 0, because it was their maximum velocity. When it will go close, repulsion started, then velocity will start what? Decreasing due to the repulsion. And in this point it will reach, for a fraction of second it will stop over there, and then it will start come in a opposite directions. So now here potential energy 0, then kinetic energy 1, which will be equals to half into mass into velocity square. Everybody knows kinetic energy equals to half into mass of the particle into velocity square. Now in the point 2, total energy 2 will be equals to kinetic plus potential, which is nothing but a half into mass into velocity, that moment velocity square, plus potential energy which will be 2. And potential energy, we know if there are 2 charges there, potential energy will be equals to K into Q1 Q2, suppose Q1 Q2 2 charge by what? R. And if the like charges is there will be positive sign, unlike charges will be there, means negative sign. K is nothing but a related to permittivity factor, which K value is 9 into 10 power of 9, which is nothing but a 1 by 4 pi epsilon naught. Now if you look at in the point 2, my total energy is T2, which is nothing but a half into mass into velocity, that moment square, where velocity will start decreasing from this value. Why? Because due to the repulsion, positive velocity will start decreasing. And in the point 3, total energy is nothing but a T3, which is nothing but a K3 plus P3. Whereas my K3 will be what? 0. For fraction of moment, my kinetic energy part will be 0. Then already total energy is nothing but a potential energy 3. Then immediately if you look at, my dear student, potential energy is 3, which is nothing but a T3. Then I can apply as per the conservation of energy, conservation of energy. Conservation of energy. What I can write down, my dear student? I can write down T1 will be equals to T3. So then T1 is nothing but a only kinetic energy, which is nothing but a half into mass into velocity square, which will be equals to T3 is nothing but a potential energy, which is nothing but a K into Q1 Q2, two charge Q1 Q2 by R, and that distance is nothing but a R naught in this point, Q1 Q2 by R naught. Now you look at the mass of alpha particle, you will keep over here 4 into mass of the proton, which is nothing but a 4 into 1.67 into 10 power of minus 27 kg. Everything I am keeping in SI unit. Then velocity already they told, which is nothing but how much? 2 into 10 power of 5. With this velocity it is leading. And here we consider velocity is not decreasing for that moment, but middle point, if they give you calculation, they will give that moment velocity. Here we are considering velocity is initially what is there, that velocity we are considering over here. But middle point, if I want to calculate, they have to tell that moment velocity how much. Because this is the initial point kinetic energy, that's why initial velocity 2 into 10 power of 5 I keeping. And this is the K value you will keep 9 into 10 power of 9. Q1, if you look at Q1, if you take the charge of the copper atomic number is nothing but what? 29. JD, charge of the nucleus will be nothing but that many number of proton will be there. That's why 29 into charge of proton. Charge of proton is how much? 1.6 into 10 power of minus 19 coulomb. Then Q2 is the charge of alpha particle 2 unit, which is nothing but a 2 into 1.6 into 10 power of minus 19 coulomb. And now you look at all the value we know, one equation only one unknown is there, other we already put R naught. This R naught will be the closest distance in meter unit. Why? Because everything we put in SI unit. Is it clear? I am just giving a briefing. What we do over here? Just simply apply the conservation of energy. Initial point total energy is nothing but only kinetic, which is half into mass into velocity square, and the mass you know already, the mass of alpha particle is nothing but a 4 into mass of the proton or Newton. Then velocity they mention, K we know 9 into 10 power of 9. Q1 is the charge of nucleus of the copper, which is 29 into charge of 1 proton. And then Q2 is the charge of alpha particle, which is plus 2. Charge of 1 proton is 1.6 into 10 power of minus 19 coulomb. Proton is a symbol of a 1 plus charge. So that's why here 2 proton means 2 into 1.6 into 10 power of minus 19. This is the entire equation, and we equate at energy as per the conservation of energy. Always you remember T1 will be equals to T2 will be equals to T3. So then T1 equals to T3 we equate. That means initial kinetic energy will be equals to the final potential energy. Final point for the fraction of moment, kinetic energy will be 0. And that we equate and keep all the values. From there I will get the R naught. Is it clear? Okay. Then if you look at next another important model, the number of alpha particles scattered, number of alpha particle scattered at an angle of theta per minute expressed by this formula, which is n theta will be equals to some constant sine to the power 4 theta by 2, where n is a number of particles scattered per minute, number of particles scattered per minute. K is a constant. That means n is inversely proportional to 1 by sine to the power 4 theta by 2. Now, based on that, if I give a one problem, my dear, how you will solve that problem? I am telling add 60-degree angle, scattered particle means alpha particle per minute is 100. Then number of particle scattered at 90 degree per minute will be equals to how much? That is a question. Now what we can do over here? Suppose 60-degree angle scattered particle I am taking N1 and 90-degree scattered particle I am taking N2. Then immediately I will apply these things, this formula derivation is not there, only you have to remember this one. The number of particles scattered per minute in Rutherford experiment, which will be N, will be equals to K by sine to the power 4 theta by 2. And then if I take N1 by N2 ratio, then proportionality constant will be cancel out, K, both cases proportionality constant will cancel out. Then N1 will be inversely proportional. Here N2 means what I will do? Sine theta by 2, theta means here N2 theta, they are inversely 90 by 2. And this will be what? Whole power 4 by sine here 60 by 2 whole power 4, which will be equals to, this is 90 by 2 means sine 45 to the power 4, here sine 30 to the power 4. Now sine 45 value is 1 by 2, I think, 1 by 2 to the power 4, sine 30 value is 1 by root 2 to the power 4. Then this will be your 1 by 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, 1 by 16, then root 2 into, this will be your, these things will be below by 1 by root 2, 1 by root 2 to the power 4, 1 by to the power 4 means 4, root 2 into root 2, 2, again root 2 into root 2, 2, 2 into 2, 4. So then this is nothing but a 1 by 4. Then we are getting 1 by 16 into 4 will come, which is nothing but a 1 by 4. Then my N1 by N2 is coming 1 by 4. Now N1 value is there, how much? N1 value is there 100, they are telling. 100 by N2 will be equals to 1 by 4. Or if you look at over here, this N1 by N2 is nothing but this scenario is coming. So I feel sine 45 is 1 by root 2. I did it this thing. This will be your 1 by 2. Here little change will be there. This will be 1 by root 2 and then immediately here it will be 1 by 4 and here it will be 1 by 16. And then immediately you will get like this situation 1 by 4 by 1 by 16, which will be equals to 1 by 4 and this 16 will go up. This will be equals to 4. Instead of 1 by 4, this value little bit you change. Sine 45 is 1 by root 2, sine 30 is 1 by 2. And then immediately what I will get over here? Then 100 by this N2 is nothing but a 4. Then immediately if you look at N2 will be equals to, N2 if I take these things, then 100 by 4 will be equals to what? N2. So then this will be nothing but how much? 25. Then your answer will be nothing but how much? 25. Is it clear, everybody? Okay. So these are the important topic. To get like this type of videos, please come have a look and watch and be confident for your upcoming exam for JEE Mains Advance and proceed with Kunal Sir's Chemistry. Thank you very much. Thank you all, my dear student.